Hey guys, today we're going to look at our second part of curve sketching. We're going to look at critical points, including local maxima and local minima. Okay, so first of all, let's look over what these things mean. To have a local maximum, we have discussed this in other units, but if a function has a local or relative maximum at any value of x equal to c, it will look like this. It will be either what we call a stationary point, which is just your standard turning point, where it's like a curve, you know, where it just gets to the point where the slope becomes zero, right? Okay. Alternatively, we can have a cusp point or a corner point. Now, it is a little difficult to see the difference here. A corner point is just a little bit like it'd just be like you're going in a line and then maybe you switch into a parabola or something like that. Okay, the difference between that and a cusp point, and we'll see some examples of this, but this is where the derivative at this, or the derivative here would actually, it doesn't exist, but it's because it actually ends up, the tangent at that point would actually be a vertical line. Okay, so there is no slope. All right, so that's the difference. It's a little tricky to see, but you'll see examples and it'll make a little bit more sense. And of course, a local minimum, it's exactly the same. It's just that it's turning the other way. So for instance, you know, we've got, if we had an upside up parabola, that would give us a local minimum. Or we could have this cusp or the corner point, just sort of pointing down. Okay? All right, so the other things that can happen, which we'll see, these are considered critical points, but they are not maximum or minimum points, is you could have and you would see this in like a cubic or something, where the derivative at this point, you can see the tangent is horizontal, so you would have that derivative equal to 0, but it's not a maximum because it just continues to, or in this case, or a minimum, it continues, it's going down, it gets 0, but then it just continues back to going down. And this one, same idea, it's going up, and then it continues to go up. Now this one, it would not exist because, of course, there is no slope of a vertical line. Okay? All right, so if we look at critical points, so any of these things that we just talked about are critical points. And that does include these here, which we said were not maximum or minimum, but those are also considered critical points. So the criteria for it to be a critical point is that either the derivative of the function evaluated at c has to either equal 0 or it doesn't exist. Okay, and that will take care of all of those situations. Okay, so either the derivative equals 0 or it does not exist. Okay, so what we can do when we're testing for these things, we do what we call the first derivative test. Okay, and this is fairly simple. It's fairly similar to what we've already done. Here, let me just do that. Okay, so if the derivative changes sign from positive to negative, positive to negative at x equals c, then this would be a situation where f has a local maximum. And you can see that this is true over here. You can see the slope is positive right here, and then it changes at this point to going negative, and so that would be a local maximum. And the same is true whether it's the cusp or the corner point. Okay. Similarly, if it's going down and then changes to positive, and then changes up, then it would be going from negative to positive. That's a little messy, but that's okay. And this would mean that it had a local minimum. Okay, there we go. If, however, the derivative does not change signs, then then it neither has a max or a min. And we'll talk more about what those are. These blanks don't really make sense, but we'll say neither max nor min. Oh, that's not how you spell min. Let's see. So okay, so if it doesn't change signs, it doesn't have a max or a min. You can see this one, it's going down. Okay, it hits 0, but then it continues to go down. So that's an example, and you can see it's not a max or a min. Okay. All right, so I want you to try these next 2 examples, and then we will take them up in class. Okay, so until next time, go Sabres.